Alright, this is another real world situation. We're talking about the Royal George Bridge or Gorge Bridge, whatever. It's the highest bridge in the U.S. and the deck is 1,053 feet above water. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water, assuming there is no air resistance? So you might be thinking, that's super confusing, but it's not because they give us the formula. It says use the formula h of t equals negative 16t squared plus h naught. That's how that's read. H sub 0 is called h naught, where t is time in seconds and h naught is the initial height above the water in feet. So we have to do a little bit of figuring out here, and it's not super hard. We need to figure out what h naught is, because if we don't know that, we can't solve for h of t. So we know that the deck is 1,053 feet above water, above the river, and we're holding it 3 feet above that. So the total feet that we're holding above here is 1,056 feet. So that's what our h naught equals. So our equation now reads h of t equals negative 16t squared plus 1,056. So that's what we're going to now type into our calculator, because we're going to use our calculator to help us solve this. And again, we're going to be solving for the x-intercepts because we want to know when the height is 0. When it hits the water, that's a height of 0. The water is our ground. So we need to type this into our calculator. So if you're in anything, hit second mode, which is quit, to get out of there. Go into your y equals, clear out whatever you have in there, and now we're going to type in negative, not subtraction sign, but negative 16, and instead of t we use x. Okay, don't worry about the variable. You have to use x actually in the y equals, because that's what it knows is the input. So negative 16x squared plus our h naught, which we said was 1,056. Okay, then go ahead and hit graph. And you're going to notice that you just see a line. That's because our graph scale is very off. Oh, and then it came back down. So we know our peak happens in between those two lines. They look like lines, but they're not really lines. And that it's opening up. It's opening down because it had a negative a value. So we know we want to go up rather than down. So we're going to adjust our window here, and let's be smart about it. If we go back to our equation here, we don't have negative time, so we don't need to go into the negatives for x. We will show some negatives so we have a nice picture, but really don't need negative time. And then we're all the way at 1,056 for our height, so we need to go up that high at least and down to 0. So we need to go to window. So for our x-min, let's do like negative 2, and max is fine at 10. We'll go by ones. And sometimes it likes to change these newer calculators. I don't like that, so I'm going to go down and change that in a second. And then our y minimum, let's make it negative 10, just so we can see the picture better. And then our max is going, well, let's make it negative 100. And then our maximum is going to be 1,100, and we will go up by hundreds. And then I'm going to change, some of you don't have this, but I'm going to change the x to go up by ones because I don't like them telling me what to go up by. And then once you're done with that, you can go to graph. Ooh, something went wrong. Back to window. Okay, well it changed my x max. So if you do have a new calculator, do not change this because it's just going to change it for you. So we're going to change my x max back to 10, not 262. So that's one thing I don't like about these new calculators. And then it should be fine from there. So if you look down here, it gives me a preview of my graph on the software so I can see it's nice. So I'm going to go to the graph and I can see that nice peak, which is my vertex, and my highest point is going to be where I drop it from. That's expected. So my vertex is at x equal to 0, which is time equal to 0, because that's where I dropped it from. It's not going to be any higher than from where I dropped it. And we're trying to find this right here. When did it hit the ground? After how much time, which is our x value, did it hit the ground? So I can see that's between 1, 2, 3, 4, 5, 6, 7. It looks between 8 and 9, but our scale is, they put our y scale as, or our x scales as 400ths, so that's not accurate. So that's a thing, another reason why you can't really go by that graph always, because your scale is going to be different with these new calculators. So to estimate this, we're going to go to second, trace or calc. This is like I did in the second part of the last example. Oh, just kidding. This is the first time you'll see this because I did the other example first. But we're going to go to 0, and what we're going to do is, so I'm going to go back to that. Second, calc, and we're going to choose the 0 function because we're trying to figure out when the output is 0. And then we're going to go to the left of the 0 because we're trying to tell the calculator where to look. So don't get too close so you don't overshoot it. Hit enter, and then you need to tell it to where to stop looking, so go to the right of that point, hit enter, enter one more time, and then it spits out an estimate of 8.12. So that's seconds. So it took the whatever we dropped a marble, and it would take about 8 seconds to land in the water. And that's it for number 6. And just kidding, I guess this was the last example, so you have done this before. But that's how you do it in a real-world situation. So you will have this H naught or N naught or whatever your input is on one of your homework problems. So just remember, you got to figure out what that is before you can actually solve it. And be sure to bring your graphing calculator home because you need it for your homework.